Hello, everyone. My name is Kai Rodriguez, and I'm an undergraduate biology student at the University of Central Florida and research associate with the Blue Marble Space Young Scientist program. During my time in this program, I've had the opportunity to begin working with researchers in astrobotany and astrobiology. My work so far has involved two main projects, the Titanium Card Astrobotany Reset Item and the BioSim Research Project. I'd like to talk a bit about those projects, what I've learned from them, and how this experience has influenced what I want to pursue in the future. First, let me introduce you to the Astrobotany Reset Item. It's currently a document that is intended to be engraved onto a titanium card. Titanium was chosen as the material to be used for this project due to its high melting point of 1,668 degrees Celsius or 3,034 degrees Fahrenheit. The purpose of the card is to preserve a summary of our current understanding of astrobotany in a format that can survive for an extremely long period of time. The big picture behind it is that, even if our current civilization were to disappear, the information would hopefully remain and provide future generations with enough scientific background to understand, and eventually use as a jumping-off point to recreate some of the experiments and research that we're conducting today. I had the pleasure of assisting Gil Cawthorne and his team with polishing and drafting parts of the final document over the course of this internship, and I learned quite a bit from the process and the text itself. This project deepened my understanding of how scientific communication should be conducted, as one often assumes that the general public has access to textbooks, scientific literature, equipment, and other assets that would allow someone to research further into a topic if desired. With this project, we had to think about what happens when none of those things can be assumed. We must ask questions like what information is strictly necessary, how much background knowledge must be included, how can an experiment be written clearly enough that someone in the future could manage to reconstruct it. I found this mental exercise quite valuable, as it opened my eyes to the fact that it isn't enough to simply conduct an experiment and publish the results. We also have the responsibility of considering how that knowledge is communicated, and how it will be passed on for the foreseeable future. Now, let's turn to the second project I was introduced to, the BioSim Research Project. BioSim is a Java-based simulation of an integrated advanced life support system. In other words, it's a simulation of what an extraterrestrial self-sustaining base could look like, with features that allow one to consider and test the necessary variables for a successful space mission. The simulation is designed around the kinds of interconnected systems that would be important during a space mission, such as water, oxygen, food, and energy management within a closed system. I was tasked with investigating the simulation and asked by Luke Consolato to develop a potential research question that could be tested using the BioSim. Since a final research question is still being developed, I'm focusing on delving into the code and documentation, identifying the many variables and scenarios to best make use of this simulation. This experience has been valuable as it's given me exposure to a part of research that I believe can be easily overlooked, which is determining whether a question can be scientifically tested based on empirical evidence. It's very tempting to start with a broad question, but we must define measurable limits, what part of the simulation we plan to change, what variables are intended to be measured, and what we would consider a meaningful result. I haven't had the chance to work with an editable scientific simulation tool before, and this experience has given me a better appreciation for how these types of tools can be used alongside biological research to make testing these theoretical scenarios much easier before committing to a more difficult, expensive, or impractical experiment. This connects to an overarching idea that I've learned during this internship. Now, research is more iterative and detailed than I expected. I feel like I've been taught a lot about how collaborative research functions, and I've still only scratched the surface. Everyone I've worked with has come into this program with different interests and life experiences, and those differences affect the kind of questions we ask and the ways in which we can approach them. Personally, this internship has bolstered my passion for what I wish to do professionally. I want to have a career in astrobotany that allows me to contribute to our understanding of plant physiology in space, with the aim of making future expeditions into deep space possible. Having the opportunity to work with my mentors, Rafael Luerio, Gil Cawthorne, and Luke Consolato, has given me the opportunity to see what research in astrobotany can actually look like. And although my internship period is coming to an end, I'm not planning for my involvement for the group to end here. I plan to remain involved with the Blue Marble Space Program as a visiting scholar, and I hope to continue working on current and future projects under the wonderful team that's taken me under their wing. This experience has made me more confident that this is the field I want to pursue, and I'm very grateful to everyone at Blue Marble Space who has given me the opportunity to take those first steps towards my dream career. Thank you for listening to my talk, and here's to seeing what questions we can answer next.